Based on the data provided by the Department of Statistics Malaysia, Malaysia's crime index in 2024 rose by 11.1%, with 58,255 cases reported as compared to 52,444 in 2023. This increase was largely driven by property crimes, which surged by 12.4% to 47,188 cases. Assault crimes also saw a modest rise of 5.9%, totaling 11,067 cases. The rise of crime cases in Malaysia has been a concern as it puts the life of the citizens at a higher risk of being the next victim, further contributing to the rising crime statistics. This matter of relevance brings us the question on how to lower the crime rate and how to solve the crime cases. Therefore, there is a need for stricter law enforcement and advanced forensic investigations.
Good evening and welcome to Crime Science Today. In modern forensic investigations, one instrument has become one of the most powerful tools for uncovering hidden evidence, the gas chromatography mass spectrometry, better known as GCMS. From detecting deadly poisons to identifying drugs and the accelerants, the technology helps forensic experts reveal the chemical truth behind suspicious death and criminal cases. Today, we're joined by two experts, forensic scientist Shamil and lab equipment engineer Danish. Thank you both for joining us. Danish, let's start with the basics. What exactly is GCMS?
Okay, thank you Anna. I'm Danish. So GCMS stands for gas chromatography mass spectrometry. It is considered one of the most reliable analytical instruments in forensic science today. So I like to describe it as an elite two-man detective agency because separately each part is powerful but together they are nearly unstoppable. So the first part of gas chromatography, or from the short form which is GC, its role is to separate complex mixtures into individual compounds, and the second part is mass spectrometry, in short is MS. So once the chemicals are separated, the MS identifies them by producing a unique individual spectrum for each substance, and together the system allows forensic science to detect and identify drugs, toxins and poisons and other chemicals with extremely high accuracy.
That sounds incredibly advanced, Shamil. Why is this technology so important in forensic science?
So GCMS is important because forensic samples are usually very complex. For example, blood samples may contain medicines, alcohol, illegal drugs, or even toxic chemicals all mixed together. Without proper separation and identification, it would be difficult to determine what substances are present. So the GCMS help us to separate those chemicals and identify them accurately, even in extremely small amounts. Because of its reliability and precision, GCMS results are widely accepted in court as scientific evidence.
Danish, could you walk us through how the machine actually works step by step?
Of course. So step 1 is injection and vaporization. First, the forensic sample is prepared and is injected into the instrument. This sample could come from blood, urine, fire debris, or even residue collected from clothing or weapons. And inside the GCMS is then heated and vaporized into the gas. Step 2, which is the separation process. Next, the inert gas, which is carried on here, it pushes the vaporized mixture through a long column, which is this, and is then the different chemicals interact differently with this coating. So lighter compounds move quickly, while heavier or stickier compounds move more slowly. For step 3, which is separation, so because each chemical travels at a different speed, the mixture becomes separated into individual compounds. Instead of arriving together, the chemicals exit the column one by one through the transfer line in pure form, and the entire stage is called gas chromatography. So, for the mobile phase is the inert carrier gas, which is located here, and the step 2, which is the GC column coating, which is the stationary phase, which happens here in the GC column, and that is all for the gas chromatography. So, for step 4, we will be moving on to the mass spectrometer, which is the analysis part. And as each isolated chemical exits the column, it enters the mass spectrometer, and here the molecules are bombarded with high energy electrons, and which breaks the molecules into smaller charged fragments, almost like smashing glass object into unique pieces. Lastly, which is the detection and identification. So the fragments then move through a magnetic field, which is the mass analyzer, and according to their mass to charge ratio, will be separated, and the detector records the pattern and generates a mass spectrum as the data system, and that spectrum acts like a chemical fingerprint unique to that substance. So the system then compares the fingerprint against large forensic databases containing thousands of known compounds to identify the unknown chemicals.
So, essentially, the GC separates the chemicals and the MS identifies them?
Exactly! The GC organizes the mixture and the MS confirms the identity of each compound with remarkable accuracy.
Shamil, what kinds of forensic samples are commonly analyzed using GCMS?
So the GCMS is used in many areas of forensic science. Some common samples include blood and urine samples, tissue samples from autopsies, fire debris, body substances suspected to be drugs, food and drink samples in poisoning investigation, and also in chemical residues found on clothing or weapons. This is because the instrument is extremely sensitive and it can detect even trace amount of chemicals.
Can you share some real forensic situations where GCMS becomes essential?
Absolutely. In overdose cases, GCMS have identified toxic drugs or alcohol levels in blood samples. This have determined whether substances contributed to a person's death, and the GCMS is also critical in suspected poisoning investigation. For example, it can detect pesticides, anti-freeze chemicals, industrial toxins, or illegal substances hidden in food and drinks. In fire investigation, GCMS can identify accidents such as gasoline or kerosene in fire debris. This helps investigators determine whether a fire was accidental or intentionally started.
That means the machine plays a role in both criminal investigations and death investigations.
Exactly. It's about forensic toxicology, narcotics analysis, and arson investigation, and many other forensic disciplines.
Danish, from a technical perspective, why is GCMS considered such a trusted instrument in court?
There are several reasons. So first is the system provides highly accurate chemical identification. Second, it can detect substances in extremely tiny quantities, even down to trace or nanogram levels. Third, the machine produces objective scientific data, which reduces human interpretation errors. And finally, the results are reproducible and scientifically validated, making them highly reliable for legal proceedings.
Shamil, final question. How does the GCMS strengthen forensic investigations overall?
So the GCMS strengthens forensic science by providing clear scientific evidence because it helps like determine cause of death, confirm the presence of illegal drugs or poisons, connect suspects to crime scenes through chemical traces, and support investigators with accurate laboratory findings. Ultimately, it improves the quality of forensic investigation and helps the justice system make informed decisions based on the scientific evidence.
Thank you, Shamil and Danish, for sharing your expertise today. From solving poisoning cases to uncovering evidence in arson and drug investigations, GCMS has become one of the most powerful tools in modern forensic science. It's a reminder that behind every forensic breakthrough is a combination of science, technology, and expert analysis working together to uncover the truth. I'm your host, Aina, and this has been Crime Science Today. Thank you for watching.